Hi guys. Today we're going to go over Honors Chemistry, Chapter 9, Section 2 on ideal stoichiometric calculations. We're going to start by converting from moles of A, that's our given, to moles of B, that's the unknown. Okay, so in order to convert from moles of one thing to moles of something different in a reaction, you're going to multiply by the mole ratio. Let me underline that in red. That is how we do it. Okay, now you guys know from yesterday, there are many different mole ratios in an equation. So we have to know which mole ratio to use. And that is this part right here. You're going to use the mole ratio where the given unit and compound are on the bottom and the unknown unit and compound go on the top. Okay, so that's how we know which one to use. Let's do an example. Example A is the easiest type of stoichiometry problem. The equation is balanced. The coefficient 2 in front of LiOH is highlighted because that 2 is going to need to go in our mole ratio. And the question says, how many moles, okay, so I know I'm looking for moles. Let me underline that. How many moles of LiOH? So that's our unknown. Okay, our unknown right here is moles of LiOH. And so I've written it for you guys this time. Are required to react with 20.0, that's our given, moles of CO2. So I've written out the given. 20.0 moles of CO2 is where we're starting. The average amount exhaled by a person each day, that is extra information there to confuse you, so we get to ignore that last little bit. We don't need it. How do I solve that problem? Well, we always start by writing the given. So 20.0 mole with the unit, mole, and this time we have to have that compound written down. So no being lazy, we got to write that CO2 out over 1. And this is where that mole ratio comes in. A mole ratio is just 2 parts of the reaction, my balanced reaction that we have to have. That's our balanced equation. EQN, short for equation. And the given CO2 and the given unit, mole, those go on the bottom. Mole of CO2. Okay, what goes in front of the CO2? That's the coefficient from the equation, and there isn't a coefficient. So that means there's just 1 mole. Okay, on top, I'm looking for moles of LiOH. So that goes up top, mole LiOH, and that's where that 2 comes in. So there's a 2 in front of LiOH in the equation right here. And so I have 2 moles of that, lithium hydroxide is what that is, for every 1 mole of carbon dioxide that's going to react. So this is a 2 to 1 mole ratio. What would my answer be? That's really easy. 20 times 2, it's 40. We want to keep sig fig, so I'm going to put 40.0 with the unit mole and the compound LiOH. So that is our final answer. Okay, hopefully that was not too hard. We wrote the given, we multiplied it by the mole ratio where the given unit, mole, and the given compound, CO2, were on the bottom, and the unknown, the one we're looking for, LiOH, goes on the top. Okay, let's do a little bit harder problem where this time they're going to ask us for grams and not moles. So we're still starting with moles of A. So we're going to be given a certain amount of moles of something, but this time we want to change it to grams at the end. So we're not going to end with moles, we're going to end with grams. The steps to doing this are we're going to multiply by the mole ratio. Let me use a different color. Let's use turquoise. So we are going to multiply by the mole ratio just like we did in that last problem. Then we're going to multiply by the molar mass of B, and you'll see why in a second. So the question for this example is, what mass in grams of glucose is produced when 3.0 moles of water react with carbon dioxide? It's not telling us how much carbon dioxide, so we're going to assume that we have enough carbon dioxide to react with all 3 moles of water, okay, in this plant. So we're going to solve this by writing the given number of 3.00, 3.00 mole H2O. Okay, and are you guys yelling at the screen, but wait, we don't have a balanced equation? You're so right. We can't do this problem without one. It says glucose produced from water and carbon dioxide. That sounds like photosynthesis to me. Photosynthesis looks like H2O plus CO2 makes C6H12O2 and oxygen. Okay, and that is not balanced. You guys can go ahead and try balancing. I know that there's 6 waters, 6 carbon dioxides, and 6 oxygen molecules to balance that out because of the glucose formula there. So now we have our balanced equation. I need that because I have to multiply by a mole ratio, and I don't know the ratio without the balanced equation. Moles of H2O are going to go on the bottom. Moles of H2O are unknown. The one we want is how much glucose is produced. So moles of glucose. I don't know grams yet. Okay, so that's really important. In a mole ratio, we can only put moles there. Okay, so we have to first change it to moles and then we can get to the grams that they're asking for. And what's the ratio? There's only 1 glucose for every 6 water molecules. So that's a 1:6 ratio. And again, I got that from that 6 in my balanced equation. This 6 right here becomes a 6 in my mole ratio. And I'm not done yet because it said how many grams. So I need to find out in 1 mole of glucose, how many grams is that? H12O6, and I believe it's 180.18. I'm going to be lazy and Google it, which you guys would never do, right? It is, I don't know why Google always gives you the wrong answer. It's not 180.15, it's 180.18. So I'm going to use my own brain to remember it's 180.18 grams of glucose. C6H12O6. Okay, and moles of water are going to cancel with moles of water. Moles of glucose cancel with moles of glucose. And I'm left with the units I want, which is grams of glucose. So I just need to plug this all into my calculator. So I have 3 divided by 6, that's 1/2, times 180.18, that's 90. Whoops, should not be 1800. I had 0.5 times 180.18, 90.09. 90.09, and that is my final answer for that problem. Whoops, sorry, cut the 9 off there. Let's undo. That's my final answer right here. I'm just going to underline it. And let's underline the 40 from our last one. Okay, so that's how you do a moles to grams problem, meaning we started with moles and we ended with grams. Let's look at a grams to moles problem, the opposite. So in this one, we're going to divide by the molar mass of A first, and then we're going to multiply by the mole ratio second. Okay, and here's why. Our given, this is my given, is 824 grams of NH3. We actually have 2 problems here. How many moles of NO2? So moles of NO2 is my unknown number 1. And then second problem, how many moles of H2O? Okay, so those are 2 different problems that we get to do. Yay. And we have 824 grams of NH3 over 1 times, okay, so I'm starting with grams now. I can't multiply by a mole ratio if I don't have moles yet, because I would have moles on the bottom and grams and moles don't cancel. So I need grams down here below. Okay, grams of NH3 is what I need in order for them to cancel. How many grams are in 1 mole of NH3? Well, nitrogen, let's do it in red. Nitrogen is 14.01. Each hydrogen is 1.01, and there are 3 of them. So that's 3.03. So that's 17.04 grams per mole for NH3. So that 17.04 goes right there. Okay, so I'm going to divide by the molar mass. And now that grams will have canceled, now I have moles of NH3. So now my moles of my given can go on the bottom, moles of NH3, and the moles of my unknown go up top, moles of NO. Okay, and that's what it asked me for, was moles of NO, so I get to stop right there. And I did not plug in my mole ratio, so let's do that. What's in front of NO? That's a 4 in front of NO. NH3, oh, also 4. Guess what? Those cancel out. I don't even have to do anything. It's just 824 divided by 17.04. And the answer is 48. Let's see how many sig figs. We had 3 sig figs, so it's 48.4. 0.4 moles of NO. I'm going to let you guys try problem B. It's the same exact setup, except now we're going to have, actually, I'll do it with you guys because I'm just going to use my eraser. Instead of finding NO, I need to find H2O. Is that cheating? It's cheating a little bit. Okay, so I'm not looking for moles. And now I'm looking for moles of H2O. And so in my balanced equation, that's not going to cancel anymore. I still have to divide by the molar mass of NH3. But now this time, NH3 is 4, okay, from the balanced equation, and H2O is 6. Okay, so mathematically, I could reduce that to 3/2 if you want, but it shouldn't make a difference. I'm going to do 824 divided by 17.04 times 6 equals divided by 3. Ooh, divided by 4. 72.5. 72.5 moles of H2O. So write out your unit, write out your compound. All right, so that was B. And last but not least, this is the whole enchilada where we are starting with grams and we're trying to end with grams. Okay, so the question says, how many grams of SNF2 are produced from 300 grams of HF? So we're starting with grams of HF and we're ending with grams of SNF2. So here's what we're going to do. We are going to take, I'm starting all the way to the left because it's going to be a long one, 30.00 grams of HF over 1. All I did was write my given with the unit and the compound over 1. I need grams on the bottom since I'm starting with grams of HF in 1 mole of HF. That's the definition of the molar mass, is how many grams are in 1 mole. Let's not cheat. Let's use my periodic table here. So on the periodic table, fluorine is going to be 18.998. That's 19.0. Okay, so that's 19.00 plus hydrogen is 1.01. So that's going to be 20.01 is my molar mass. Okay, and now grams have canceled. Now I have moles of HF, and I need to get rid of those moles of HF. And I need to convert it to moles of my new thing, which was the one they wanted was SNF2. This mole over mole, this is my mole ratio, and it comes from the balanced equation. Okay, so my balanced equation right here is going to give me my mole ratio. In front of the SNF2, I have a 1. In front of HF, I have 2. Okay, and now moles of HF will cancel moles of HF. It did not ask us for moles of 10 fluoride, that's SNF2. It asked us for grams, so I have one more step. In 1 mole of SNF2, how many grams of SNF2 would that be? Okay, let's add that up. Fluorine was 19. What's 10? 118.71. That's 118. 0.71. 19 times 2, I should be able to do it in my head, but I can't. That's 38 plus 118.71. Okay, so that's 156.71. 156.71 because I added that 38 right here. Okay, all right, let's do the calculations now. I have 30.00, which is just 30, divided by 20.01. I'm going to hit equals and then divide by 2. Divided by 2 equals, and now I'm going to multiply by that molar mass of my unknown, my tin fluoride. So times 156.71, enter, 117. Let's see, we had 4 sig figs because these trailing zeros are after the decimal. So I want to round it to that 4. The 7 makes the 4 round up to 5. So 117.5. 117.5 grams of S in F2. That is my final answer. Okay, so that is the hardest type of stoichiometry problem where you're given grams and you convert all the way back to grams, but of a new compound. Let me wrap this all up by drawing our value of stoichiometry. So remember that the foundation of this stoichiometry is going from moles of A to moles of B. And what we learned yesterday was you're going to use a mole ratio. Okay, you're going to multiply by the mole ratio there. That's how we change from moles of one thing to moles of another, is by multiplying by that one correct mole ratio. And you know what, down here, I'm going to put a little note. The mole ratio that you want to choose should have, I'm going to put the mole of my unknown compound up top and the mole of my given on the bottom. Okay, and then of course you have to fill in the ratio, the numbers from the balanced equation in front. Okay, so that's that. This part is just from our value of the moles. So if I start with grams of A instead of moles, I'm going to divide by the molar mass of A. Okay, because everything on the left is for A. That's my given. A equals the given compound or element, usually compound. Okay, on the right, if I want to change it back to grams, but now I have grams of B, I'm going to multiply by the molar mass of B. B is my unknown compound. That's the one we want to find how much we have. Okay, so that is our value of stoichiometry. Please have these notes filled in, and we will do some practice problems with these tomorrow. So if you're confused, do not worry. We have a lot more work and a lot more practice to do with these. Have a great day. See you tomorrow.